Welcome to the study guide video answer key. We're taking a test on scatter plots and slope. I'm just going to go through these questions one by one as quickly as I can and give you an explanation along with the correct answers. First, we'll deal with the scatter plots. What you will be asked to do is identify if it has a positive or a negative association or none at all. Three choices there. Then linear or not linear, meaning does it form a straight line approximately or is it a curve? Outliers, the things that do not fit in with the pattern. Sometimes there are outliers, sometimes there are not. And then if there is one, what's the story? So here we go. Starting first with gray hair and age. Always remember that we have XY axes here. Okay. This one is positive, right? Because it's going up from left to right. It approximately forms a line, right? Even though it's a scatter plot and there's dots everywhere, it's traveling in a linear way. So that's positive linear association. And there are no outliers here, right? Everything is contained within this certain range, okay? No outliers. That's that one. The second one, how high people can jump versus how many helium balloons they're holding in their hands. Okay? This graph is terrible and we should fix it. Here's what we should do. Let's make all the dots go this direction and put an outlier right there. Let's get rid of all this stuff over here. Here's why we want to do that. Because here is how high people can jump, and then as the number of helium balloons goes up, they can jump a little bit higher. So this is positive because it gets from here. I'm going to use red here. You can see it goes up, but it does not follow a straight line. So this one is positive, non-linear, and there is an outlier right here. This outlier, here's a person that can jump very high with no helium balloons. Let's call that Michael Jordan. Okay, so compared to everyone else who needs the helium balloons to jump higher, MJ can jump high without any balloons. So there's how you tell a story about an outlier, kind of using the X and Y values and comparing it to the rest of the crowd. Third one, height and eye color. There is no association here. It is truly scattered all over the place. It's non-linear, right? It doesn't form a line. And there are no outliers here. Very simple. Next, age of a car and how much it's worth. Oh, let me zoom out, I'm sorry. Whoo! There we go. Wow, that almost ruined your day, I'm sorry. Finally, back to age of a car and how much the car is worth. You can tell by this scatter plot as the car gets older, its value goes down. Makes sense? So this one is linear, negative, because it's going down from left to right. Remember, it's always as you're moving along the x-axis to the right, what's happening? Down, negative, linear. There's an outlier. What is the story of that outlier? It's a new car and it's not worth much. It's very inexpensive. Okay? The rest of these cars were maybe a little more expensive at the beginning, and it took them a certain amount of time to get their value as low as this one was, brand new. Okay, there's the story of that outlier. Here we have height, how tall a person is versus how much coffee they consume or drink. Okay. And we can see here that people are all different heights. And that height does not change depending on how much coffee they have. They're still this height. So, this one, there is no association, meaning coffee has no effect on the height. But it is linear. It's a line. And there's an outlier down there. Here's a person that is not very tall and drinks some coffee. That's just an outlier. It doesn't fit in with the data, has nothing to do with the coffee, because if the person was taller and drank that much coffee, they'd be right up here. Okay? So that's just someone that doesn't fit in with the rest of the crowd, but we still love them anyway. Okay? And they like coffee, so they can't be that bad. Here we go. Shoe size and hair color. No association. Not linear, because it's just scattered all over the place. And there are no outliers. Limbo bar height. Doing the limbo. And how flexible a person is. So here are people that are not very flexible, and the limbo bar is very high. Then as we move along here, and we get people that are more flexible and can bend more, we see that the limbo bar gets lower and lower. But then it stops getting lower. Why do you think that is? Well, the limbo bar can only go so low before a person just cannot physically fit under it anymore. So this is negative association, because the limbo bar is going down, 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 down. It is not linear, because it's a curve, right? It kind of goes that way. There's an outlier. What's that outlier mean? That's a person that's very flexible, but the limbo bar was very high. Maybe they're just uncoordinated. So they're flexible, but a high limbo bar. That's tough. That's like being able to jump really high, but you're not a good basketball player. That happens. That's why you're an outlier. It's okay. We're all an outlier on some graph. Here we go. Study time, grades. This kind of makes sense, right? Let's say that this is a 4.0. So this is positive because it's going up from left to right. It's non-linear because it's a curve. And it has an upper limit, right? Because your grades can only go so high. So even though you can study more and more and more, it's not going to make your grades go above a 4.0. So they're going to flatten out eventually. This outlier is simply someone that doesn't study much and they get good grades. That can happen that way. Okay, that's fine. Last two, how long someone's nose is and how many lies they tell. Okay, so we have people with different lengths of noses. By the way, there is no association here, because it doesn't seem to matter how many lies people tell. Their nose length stays right in this range here. It doesn't grow or shrink. Okay, so it's linear. It makes a line. And the outlier over here is Pinocchio, right? Here's someone whose nose is very long and they tell lots of lies. That would be the Pinocchio outlier. Finally, the amount of food eaten, if you can't read that. So, they eat more food, they get less hungry. Negative association. It's linear because it forms a line. Out here, I had someone in class say that that's the Cookie Monster. Sometimes it's easy to tell a story about an outlier if you can identify someone specific. Cookie Monster. No matter how many cookies he eats, he is still hungry for cookies. Still hungry. Okay, that takes care of that side. Here we go. Flip this over to the slope side of the study guide. We're just trying to put these in order from the steepest to the flattest. Okay, greatest slope to not the greatest slope. Okay, remember, it's always moving to the right. Always moving to the right. So here we have a slope of 1/2. Here, there's no numbers, but we could tell that this has a slope that's probably a whole number, right? Because the slope of 1/2 would be up 1 and over 2. Would look kind of like that for A. So A is not as steep as B, and we don't even need to know what B is to figure that out. C, as X is increasing or going to the right, Y is going down. That means negative. So B is the steepest, A is next, C is next. C would look like this if we had it on the graph. Okay? Going on to number 2. A definitely looks the steepest, doesn't it? The problem is, as we move to the right, A is going down, which means it's negative. Okay? So that actually has the flattest slope. B finishes up here, and some people might go, oh, that has the greatest slope because it's the highest ending point on the line. But consider this. If you take the line C and move it up here so it starts the same place that B starts, it's easy to tell that it's steeper. Okay? So the only difference between B and C as far as ending in a different spot is that they have a different y-intercept. Y-intercept has nothing to do with the slope of the line though, so don't be fooled by that. C is the steepest. So these are going to go, C is the steepest, B is next, and A is negative. So that's last. That's number 2. Number 3. We have 3 linear equations, 2 positive fractions. These both go up. This is negative. This goes down. So we know C is going to be in last place again. And the question is, which one has more slope? 2 over 3 or 6 over 7? A couple things we can do here. We could put them on a graph. We could get a common denominator, use some math to compare them. We could use a calculator. 2 divided by 3 on a calculator is 2/3, 0.6. Repeating, 6 divided by 7 on a calculator, I believe, is something like this. So we could tell 6/7 is larger than 2/3. Remember, you could do the common denominator and compare these two fractions also, right? 2/3 is the same as 14 over 21. 6/7 is the same as 18 over 21. That's larger. If you put them on a graph, you would also see that if you went up 6 and over 7 from the origin, it's going to make a steeper line than if you went up 2 and over 3 from the origin. So, the correct answers here in order are B, A, C, just like they were up here in number 1. This looks like a mess now, but if you're paying attention, hopefully you're following along and it makes sense. Okay, here we go. B has a slope of 2, which means if I start at the same initial value, let's ignore the initial value because that has nothing to do with the slope. If I start at the same spot and I go up 2 and over 1, we can tell that B has a greater slope than C. No problem. The only thing here is, now what about A? Remember, it's the change in Y over the change in X. This is Y, this is X. How much is Y changing? 15. How much is X changing? 5. That simplifies to 3, which means 3 is greater than 2, If I made a graph, A would look like that. So this one is actually just A, B, C in order from greatest to least. And finally, number 5. First thing I want you to notice is that that one and that one are equivalent. If you used a calculator and simply did 4 divided by 5, and if you did that to all 4 of these, one thing you would notice is that this is the same as 8/10, and so is that. So those are the same, and maybe on a problem like this, the easiest, fastest thing to do is simply divide the top by the bottom, meaning in this order, thinking that's the division sign, top to bottom. That might be the easiest way to solve this problem. So we can see that 5/4 is the steepest. Then it's a tie for second place with 4/5 and 16/20 because they're the same. And coming in last, 3 divided by 4, 3/4 is 0.75 or 75 hundredths. And there you have it. On the test, you need to be able to explain all of your choices using the word slope. If you've been listening carefully, I've been doing that with each one of these problems. If you need to review that, please go back to whichever problem you want. Scroll back and find it. I hope that helps, having the answer key in form of a video so you get explanations along with the answers. And if it didn't help, let me know. I'll never do it again! But if it helped, let me know. I'll do it again. That's how that works. And that is the end of this video. See you later.